The second example is about house prices in Kyburz, California, or housing in Kyburz, California, something to that effect. And I think a natural question is, if I was going to make an example about housing, why did I pick such an obscure location? The reason I picked this location is because I remembered what that welcome sign looked like, so I remembered that Kyburz was really small, and that's what I wanted. I wanted a scenario where it would be impossible to get a sample size of 40, where you'd get stuck with one that was too small, because that's the one scenario where it would be okay to have a sample size that's less than 40, and if your randomization distribution ends up looking weird, I wouldn't take off for that. That doesn't actually happen here. You'll see it later. The randomization distribution looks fine, but that's the one scenario where having a sample size that's small is actually going to be fine, if you can't get one that's bigger. This is a screenshot from Zillow of the search results for Kyburz. I made a couple of modifications to the search, which I'll get to in a second. The first thing that I want to point out is the number of results, where it says there are 22, which is certainly less than 40. However, it's really going to be 20, not 22. There are a couple of duplicates, but we'll get to those in a second. The two adjustments that I made, the first one you can see, it's right here where it says recently sold. That is not the default setting. The default setting is houses that are currently for sale. I figured that recently sold would actually give you better data because the list prices of houses that are currently for sale, that doesn't necessarily end up being what a house actually sells for. There might be some haggling involved there. But the recently sold prices, those are the actual values. That's why I went with that. At least that's one reason. The other reason is that if you switch to recently sold houses, all of the listings come out in reverse chronological order. So if you look over here at the dates, you have June 28th, June 22nd, April 27th, April 6th, February 17th, and so forth. Reverse chronological order. That way, if there are duplicates, you're going to be able to catch them right away. The other thing is where it says home type. So you can't really see this one, but I changed home type to where it was houses only. Although in Kyburz, I think that's all there was. I don't think there were any condos or anything like that. But if you use a different area, maybe you are using one where there are condos, and to keep things simple, I think you would want to stick to one type of dwelling. And that's how you adjust it, where it says home type. In this screenshot, you can see the duplicates. If you look in the upper right here, there's a house that was sold for $383,000. The next entry is another $383,000, but if you look at the addresses, they match. So throw one of those out because that's a duplicate listing. And then the same thing happens down here with the 593s. There's a 593, there's a 593. You look at the addresses, they're identical. That's another one where you can just throw one of those listings out. So instead of 22 houses that have been sold recently, it's actually 20. This is the screenshot of my constant term. The way that I got this would certainly work if you're doing something with housing that's a one sample test, but you don't have to follow what I did to the letter. What I did here was I looked up what county Kyburz was in, and then I got the home value index page from Zillow for that county. And then there's the number, 466,800, which is not a mean, it's a median, like it says down here in the first sentence, which will change the way that the hypothesis test is done. It's not going to be a test for a single mean, it's actually going to be a test for a single proportion. That's what happens when you have a median instead of a mean. It doesn't really make it overly difficult or anything, but that change does happen, or at least that change should happen. I suppose if you did a test for a single mean, you wouldn't lose full credit for doing it if your constant term was a median, but you would certainly lose something. So I got the county. If you wanted to do it for the state, that's fine too. So like I said, something similar to what I did should work to get a constant term, but you don't have to follow that exactly. The other thing that I think is worth it on this slide is the map. Because if you look at the county outline, it borders Lake Tahoe. So you think, okay, well, if there are houses for sale that are right along Lake Tahoe, those are probably going to cost a lot of money. The other thing is, where is Kyburz? It's not listed at all in that map. So you think, okay, well, that's really small. Well, I guess if the welcome sign didn't give that away, then it's being given away here. But those two pieces of information might factor into how you're going to set your alternative hypothesis up, with what type of inequality you're going to have there. There are a couple of options as far as the inequality in the alternative hypothesis is concerned. And this is not going to be a scenario where one inequality is correct and the other two are incorrect. If there's one that you can justify, then that's a correct one. The way that I think about this particular example is the first way, where the way that I look at Kyburz is it's a relatively remote rural community. I would expect that to generally be a cheaper place to live. So I'm going to look for evidence that the median is lower than the county value of 466,800. However, I can understand the two-sided perspective where you say, well, yes, it is a tiny rural community, but also it's near Lake Tahoe, maybe it's a skiing area, and that would be pretty logical considering the only famous person from Kyburz was an Olympic skier. So if you happen to know that and you were factoring that in, that would be totally logical. Again, as long as you can justify the inequality that you're using, then that's a correct inequality. I think both of these would work here, no problem. The document that I made about a test for a median would probably be helpful here because that covers every possible case. But in any event, if you're going to do a test for a median, that converts to a test for a single proportion where the null is that p equals 0.5. The first thing that you have to take care of is you have to define p. So p could be the proportion less than that value or the proportion greater than that value. You have to pick one in order to get this to work. So the way that I set this up is that I define p as the proportion of houses in Kyburz worth less than 466,800. And my hypothesis test was supposed to be one where we're looking for evidence that the median in Kyburz is less than 466,800. But when that converts to a test involving a single proportion, since I have the proportion set up as the proportion less than that number, it actually flips the inequality around. Because in order for the median to be less than 466,800, you would need the majority of the houses in Kyburz to be worth less than that, and majority would be a greater than, right? That's how that would translate symbolically. That part is kind of hard to follow, and that feels kind of weird when you're not used to it, the way that that inequality flips when you do the conversion. But that flipping inequality always happens somewhere if it's a one-sided alternative. There's nothing you can do about it. Every possible setup that's going to happen. If you need help with a test for a median, ask me about it because these are weird and this isn't a regular part of the course. But this is the right way to do it, and that's really the only part that's weird. Because when you get it down to where you're just doing a test for a single proportion, that's the thing that we've done, right? That's the thing that's in Chapter 4, so that's really not too bad. It's just that conversion part that is a little bit odd. The next thing is describing how the sample data were collected. We already saw the screenshots where it said there were 22 results, but there were 2 duplicates, so we ended up with 20 recently sold listings on Zillow, and it was restricted to houses only, so I think that would need to be included too. And of those 20 listings, 18 of them had sale prices below 466,800. You can go and check it if you want to. If you go to the CSV file for Kyburz, then you can tell just by counting. Or I guess you could set up an if statement to return a true if it's less than 466,800 and a false otherwise, or something to that effect if you wanted to do it that way. So the sample proportion, p hat, ends up being 18 divided by 20, which is 0.9. The reason that I stuck the screenshot in here is just to show that even though we have a small sample here, since 20 is certainly less than 40, if you look at that shape that's in the screenshot, it doesn't look weird. It looks symmetric, and it doesn't have multiple peaks, so it looks like we're good, even though we have a small sample. Writing out the p-value in words, this is based on how p was defined in the sense of how you could define p as being the proportion less than 466,800 or greater than, and we had picked less than. If you pick greater than, it'll give you a different outcome when you convert the hypotheses from ones that relate to a median to ones that relate to p, and then you would base it off of that. But since we defined p the way that we did, and then we got the hypotheses where the alternative is p is greater than 0.5, that's why it's the chance of obtaining a sample proportion of 0.9 or greater. That's why it's going to be a right tail, because we have that greater than the alternative hypothesis. And then, since you compute the p-value under the assumption that the null hypothesis is true, we would be assuming that p is 0.5. There's a screenshot of the p-value. The sample proportion that we got is so far to the right that there are no randomization statistics beyond it, and we end up with a p-value of 0. Since the p-value is 0, it's less than 0.05. As a consequence, the null should be rejected. So there's the statement including the p-value and the decision about the null. And if you're rejecting the null, that means you have sufficient evidence to conclude what's in the alternative, which in this case, I suppose, would be that the median value of houses in Kyburz is less than $466,800. Reservations or limitations of the conclusion based on the way the sample was taken. Of these two, I think the first one is probably going to be the more obvious one, that not every house that's for sale will be listed on Zillow. Generally, that's going to be a true statement. So that would be a reservation here. Although maybe not a big one. I don't know how many houses are really going to be left out in Kyburz, but that's certainly a possibility. The other thing is that because Kyburz is so small, those listings go back pretty far. The oldest ones that are there are from 2015, so they're up to 3 years old. So you could make an argument that some of those listings aren't current. So maybe if your sample isn't entirely up to date, then that's not necessarily going to give you the most accurate picture. That's another reservation that you could have that I think would be completely legitimate here. The CSV file, even though this ends up being a test for a single proportion instead of a test for a single mean because we have the median as the constant term, what you end up with for the CSV file basically looks like the same sort of thing that you have for the CSV file with the apples. Because you still have quantitative data, house price is still a number. You just have the single column where you have the header first. I just generically used sale price as my header, and then I put all 20 individual sale prices in that column underneath it. I wanted to stick into this video how you make the adjustments in Zillow if you're going to do something real estate related. So let's say we want Kyburz. There it is. And the adjustments that I made were that I changed home type to just houses, which it's still that way because I used the same computer. For some reason that's staying the way that it was, even though this is changing back to the default setting. But listing type is the default here, and I changed it to recently sold. So I'm going to dump all these out and just use recently sold. And nothing has changed in the past few days since I took those other screenshots. And it looks like we're getting the same 20 listings with 2 duplicates that we had before. And I suppose if you want to see the duplicates, you can scroll down and see them. There are the 383s, and then there are the 593s. As far as stat key is concerned, you don't really need to do a data import here. You can just do it as a test for a single proportion and then type your sample proportion in. I think that's going to be faster. Ours was 18 out of 20 for Kyburz. And then the null, the default setting, is actually what we want. So then it's just go ahead and generate your randomization distribution and then right tail bounded by 0.9. And that's it.